Hi, this is Matt, and in this video we'll look at example problems involving the graph of trig functions. First, we'll start by gathering information from the graph of a trig function in order to create the equation for that function. Then, we'll switch between representations of equations and graphs and try to match each together. Here we have the graph of a sinusoidal function. I need to determine the period of the function, the amplitude of the function, see if there's any vertical or horizontal shifts, and then finally write the equation of this function. So I could consider this a cosine graph, starting from the y-axis, going down all the way to 2 pi. That makes one full oscillation from peak to peak. And that's our typical cosine graph. I could also consider this a sine graph, starting at negative pi over 2, and that makes one full oscillation. Now, it's going to be easiest to consider this a cosine graph because then I don't have to consider any shifts, because a sine graph would normally start at the origin. So let's assume that this is a cosine graph. So now we need to determine, well, what's the period? Well, if this is the cosine graph, it makes one full oscillation between 0 and 2 pi. So we know that the period is 2 pi. The amplitude, the height of this cosine graph, is 4 units. So now we know the amplitude is 4. And so we can come up with, since we know that this isn't horizontally shifted, we started with cosine, it's not vertically shifted because it's centered at the x-axis. So we know that our function is going to equal y equals 4 times the amplitude cosine, and it's our typical period, which is 2 pi, so it's just cosine of x. Now, if we wanted to consider this to be a sine graph, well, we could do the same thing. We could say, well, it's still an amplitude of 4. It's sine, but now sine is shifted to the left pi over 2 units. So we could say x equals pi over 2 units. And that would give us the graph of our sine function. In this problem, we have 4 graphs of sinusoidal functions and 4 equations. Now we need to match the graph with the equation. So let's start with information that we know. Well, these 2 graphs have vertical shifts. So you can see this -2 and this +3 means that the graph is shifted from the x-axis. It's a vertical shift. So if we look at which graphs have that, A and B. So we notice that A and B are shifted from being centered at the x-axis. And so this graph here is centered at +3. If we draw a little line here, you can see that it's +3. And then it has an amplitude of 3. Well, that would be this graph. So this is shifted vertically 3, and it has an amplitude of 3. And the negative means that we're flipping the cosine. So instead of it starting at the top, it's now starting at the bottom here. So we know that these 2 are a match, which would mean that this one is matched with B. And let's make sure of that. Well, it's centered at -2, yes, and it has an amplitude of 3, yes, and it looks like our sine graph. So we've matched those 2 functions to their graphs. So we know this one is matched with A, and this one is matched with B. So we have the following 2 equations. Well, here we have 2 times sine that's shifted pi over 4 units, and the other one, 3 cosine x plus pi over 4. Well, if we go down, we know that we could use information about, well, let's use information about the amplitude. This has an amplitude of 2, and this has an amplitude of 3. So C is a higher graph, and it does indeed have an amplitude of 3 units. So we know that this is aligned with C. By default, then, this would have to be d. Now let's make sense of that. Well, yes, it has an amplitude of 2 units. It's sine, but it's shifted by pi over 4. So it starts here at pi over 4 and looks like our typical sine graph. So there, now we've matched representations of graphs to equations.